So we want to give you a brief introduction into how to use the electronics, and for this I'm going to head over to our website, that's OpenUC2, and then there's one repository that's called OpenUC2-REST, and there you find the entire firmware which is running on the board. There's a list of things you have to do in order to prepare your setup. One of them, for example, is adding a bunch of libraries. I'm going to show you how that works. And then also you have to prepare your Arduino environment in order to get the ESP32 running in the Arduino manager. Let's start with that. So you go to settings. Well, this is German, unfortunately. There's one line here which can be clicked on, and then you add a certain number of JSON files. These are just the ones that link to the repository from the ESP32, and with this you can then download the necessary files for the ESP32 IDF. So once you have done that, just click OK, you go to Tools, then you go to Board Manager. So I have it already installed. So you go to the Board Manager, and then once it's updating the index files, it takes usually quite a moment, you can just look for the ESP32 and install the firmware. So we just do that here, head over, enter, and then here you can choose the different versions. So we choose 1.06 because there is a bug in the Bluetooth configuration in the 2 version, which is anyway just nightly, so just choose the latest 1.0 version you can find and install it, and just leave it as it is right now because it's installed already. Besides that, you have to add all the different libraries. So I prepared another repository. I'll share the link in the show notes, which is right here. So if you go to Beniroquai, there's one that's called libraries, and you just download the whole thing and extract the files into the Arduino library folder. So you download it. It's a bunch of different libraries, so you don't need all of them, but that's what we're basically working with. So in Mac, all these different files are under user, well, my name, documents, Arduino libraries. So you basically just need to extract this folder here and then copy paste all the libraries in here. So you can also organize that by doing a JIT, but we don't want that to do now. So just have all of these libraries. So that's what I just downloaded from my repository here. Command copy, and then, well, in my case it's already there, just command paste. That's how that works. And then the next step would be for the repository here, just download the whole REST, UC2-REST. So we're going to do that now. Just download it here, and then once it's being downloaded, there is one folder that's of importance that's called ESP32, and here you will find all the necessary files that will be that's running the whole UC2-REST essentially. And so what you want to do now is like opening the main.ino in your Arduino environment, and then you have it like here. So the only thing which matters now is you have to choose the configuration according to your board. And once the Arduino ID let me, I will just show you here. So in the very header, there's this include pindef incubator microscope Z only matrix. This is related to the configuration you have on site, which when you go to the tab of pindef incubator microscope Z only matrix, directly links to the different pins on the ESP32 WeMOS board. So then you have the direction pins, the step pins, and also what's important, the matrix pin. Then you just uncomment the one you want to use. You go to Tools again and select the port in this case, it's this. Well, it may look different in your case, but I just know that this is the one we are looking for. You also have to install the proper drivers, of course. It could be either the CH340, so we just look for 340 drivers. So there's, it may look a bit suspicious, but you could just go to SparksFun, and then here, that link here, and they will guide you through the process. So they have a download section here. So you just download it, extract, and then install it. It's possible for Windows, Mac, and I think Linux already has it included. And once you have done all that, you might be able to not only see it here, but then also hit the compile and upload button. So this is what we're going to do now. This may take some time. The upload process has been done, and so we can test whether it worked by just simply open the serial monitor. And so the baud rate is set to this number. Choose no ending, and then when you press the reset button, you see that the bootloader is starting, and it gives you a number of possible endpoints you can call from, for example, Python or your HTTP REST API. And we are going to do that with just moving a motor. There is a very brutal set of instructions here, so you can just copy one of those. That's for moving the motor. So the task is act on the motor with a speed of 1,000 steps per minute, and then go to position 1, which is 4,000 steps, and so. Take it absolute, so don't use relative steps, and then the enable flag is basically keeping the motor current on or off. So you can either have it in the brake mode or not. So it depends a bit on whether you want to have it warming up or not. So and when we just hit enter, you see that a whole bunch of debug output is coming here, and this is the REST return, so that we are going to this position. But once we do that again, it will print the actual position, because this takes, of course, some time when it arrives there. There is also a different set of instructions. So for example, you can let the motor run forever. So for example, if you go to this command here, well, let's look for is forever. Then you can also just let the motor run continuously forever. So we just keep the speed, like for example, low speed and high speed on 2 different motors, and use acceleration and run forever. And that means like now it's running forever. And whenever we call this command again, we see that the position is getting updated internally. And one nice thing about this whole thing is also that you can provide lists. So for example, if you want to have a trigger list where you want to move the stage, make a picture, and have that completely independent from any client software, like the Python serial monitor, for example, you can also create a list. I can go into a bit more detail here, where you say, okay, I want to start with continuous acceleration, then wait for 100 milliseconds, do a camera trigger on both cameras, then turn on the laser. Despecking is basically just moving the modes a bit by doing intensity fluctuation. That then will be good for expanding the laser diode, so then the static mode pattern is vanishing at least a bit, and then turn off the laser again after waiting for another 100 milliseconds, and then you just do that here, and then it's just running through this list 9 times, no, 5 times, I'm sorry, it has 9 items and does it 5 times. And then you rely on the real-time clock of the microcontroller rather than the Python framework. This is everything I want to show you now for the software bit. And I'm showing you that this actually works also with the motor.